So with that, I want to introduce Tim Eian. I've had the pleasure of being in one of Tim's Passivhaus houses up in St. Paul, and I've just been, amazed by the work that he's doing for the Passivhaus movement. He's one of the foremost kind of proponents of the Passivhaus concept in not only the Midwest, but across the country. And so we're very fortunate to have him with us today. And with that, I'll hand it over to Tim.
Well, thank you. That's very kind. I hope everybody can hear me okay and see my screen. So as many of you, I'm working from home. My home happens to be a passive house that's under construction, hopefully soon to be done. I took that photo just 5 minutes ago, so that's literally what it looks like right now. I'm going to try to give you a brief overview today of what a passive house is, what makes a passive house, why it matters, and what we can do with it. I still have this in here. These generally qualify for continuing ed credits. While we didn't set that up specifically, I think you can still self-report if you choose to do so. I'll go over a couple of learning objectives here today, just some of the highlights I want you to be able to take away. We're going to go over performance by design. When you get into high performance buildings, some of the things that make that building tick are already solved at the desk in the architectural office or the designer's office. We're going to look at it from that perspective. We're also going to look at some of the engineering that goes into it, and then what I labeled here, Passive House in Action, showing you some examples of how one gets put together, or sort of a best of how passive houses get put together. And then I'm also going to provide you with some resources. It's a dense program. I'll try to get through here within the hour and allow for some questions along the way. So hopefully I'll cover everything that you'd like to know about the subject. Let's get on with the textbook definition, and I keep building on this a little bit. The important thing to take away here is it's a voluntary building energy standard, like many others that we have in the marketplace. The main focus of Passive House is energy efficiency, quality of life, and low operating cost. And I think that's sometimes a little bit overlooked in the conversation, where people look at it just for energy efficiency and kind of put it up on a pedestal and maybe forgo the fact that it was really meant to be a quality of life standard as well, really hinging on indoor environmental conditions and comfort. Actually, the core components of Passive House in the ISO norm are referenced as comfort criteria. And then low operating cost, and that is super important as well, because these are buildings that over their life cycle are generally cheaper than the accepted status quo. And then the piece that is really near and dear to my heart is the carbon neutrality of potential that we have here, an increasingly important subject in other cultures, an accepted subject for the last 30 years. For us, maybe a little newer than that, but this is a great pathway and tool to achieve that in the built environment. Generally, I'd like to play a little video, but we couldn't get that to work today, so I'll give you my Passive House in 90 seconds, or perhaps even less. The Passive House standard provides us with a heat load and heating demand reduction generally in the vicinity of 90% over status quo. It does that with super insulation, airtightness, the avoidance of thermal bridges. These are principles I will show you here, and I will keep coming back throughout the presentation. Other core components of it are what we call passive house windows, and we'll talk about what that means in the context of a cold climate. Proper orientation and shading. It's important to note that a passive house under the hood is a passive solar design generally. Depending on the scale and the function of the building, this becomes more or less important. Balanced heat recovery ventilation as standard. And this is something that really any new building should have anyways, and the codes are getting ever more prescriptive here. So I think this is something we're going to see universally anyways. So this is just the Passive House leading the pack 30 years ago when the standard was new, by instituting that you need balanced heat recovery ventilation. And then last but not least, this goes back to the passive solar design. We are banking on, especially in smaller buildings, single family homes, for instance, on solar heat gains and internal heat gains. So these are important components of how we provide energy to the building. So in a way, it is a solar collector and it is a battery as much as it is a building. This is a slide I'm going to reference a couple of times throughout. Here you have what is generally accepted as the 5 Passivhaus principles, the things that change from the status quo that we pay specific attention to. Again, thermal insulation, Passivhaus window, the heat recovery, ventilation, airtightness, and thermal bridge-free design. I'm going to talk about all those today, and those are the key differentiators. The basic concept, super simple. Conservation first, minimize losses, maximize free gains. So if you want to dumb it down under the hood, that's really all it does. And that's also a way out of our carbon malarkey. If you follow climate scientists, what they will tell you is that if we want to bend the curve to zero carbon, a good chunk of the way comes from energy avoidance. And that's what this is, conservation first. And then the rest of it comes from figuring out how we can bank on renewable energies. And that's what we refer to here as the free gains, passive solar internal heat gains. The name sometimes also a little misunderstood in the marketplace. The name is very pragmatic. It comes out of a paradigm shift. If a conventional building has a mediocre building envelope and relies on a large active mechanical system to limp it through the years, a passive structure, a passive house relies on these passive means on energy retention, energy recovery, those types of means to make it through the year and through the seasons. And so that's really where the name comes from, strictly going from active or dependence on active systems to a dependence on passive systems. And the numbers that you see here, we'll talk about that as well. Everything in Passivhaus is measured generally energy per square foot and year. Here we're referencing basically the heating demand, annual heating demand that we see in existing structures versus what a Passivhaus limit is. It's also third-party certified for those who choose to go down that path. You don't have to do that. That's completely voluntary. But this is what a certification of a Passivhaus actually looks like in the flesh. So on the left, you get a summary report from the certifier. In the center, the actual certificate, and then a plaque that can be mounted on the building itself. So this is what that actually looks like. And with that, I should say, come the benefits of going through third-party certification, mainly an impartial eye on the subject to make sure it actually got done the way it was supposed to get done, and then certainly the credentials that come with that. One point that I always like to make is it's really a tool for sustainable design, and that's where the Passivhaus design resonated with me more than some other programs in the marketplace, because it wasn't simply a checklist approach, but it actually delivered tools that I can use in my practice to quantify buildings and make better designs. And so if anything, I would say that's one of the core benefits provided by this program. It's not so much the certification, in my opinion, it is really the paradigm shift paired with the tools that are provided that allow me to create a known quantity in the field. And that, I think, is what is so powerful about this program. And maybe in that same vein, I should say it is energy focused. So we don't have green parameters like where's my site, transportation, landscaping, stormwater, all these other factors that are important in sustainable design. This has a narrow focus that is really targeting comfort and energy. So keep that in mind, but it pairs really well. So if you want to do a dual certification with other programs, that certainly works, and we have. So that it doesn't preclude any of that, but it doesn't do it out of the box. Metrics, as I mentioned, we have sort of our gas mileage for buildings, energy per square foot in year, and I know you're all at CEE involved in measuring, in optimizing buildings, so this is probably right in your wheelhouse as well. I think these metrics are really helpful. Where they differ from one program to the next generally is what energy and what square foot. The only thing we can agree upon is what a year is. So the devil is in the details. But generally, for a passive house, we're looking at either the what we call useful energy, that's the actual energy input into the building, or we're looking at source energy, where we track it all the way back to the plant or the origin. And these are key markers that we look at. In terms of the useful energy, the one that stands out the most here in our cold climate is the heating demand, certainly. And with that, here are some of the targets, both metric and in IP. The passive house really breaks down into 3 variants. There's an entry-level certification called Low Energy Building with passive house components that has a heating limit of 9.5 kBTU per square foot a year. Square foot, I should have said earlier, is net square feet, net usable interior. That is important, especially when you're dealing with small-scale residential buildings, just because the walls occupy so much of the footprint. So keep in mind, when we're looking at these numbers, we're using the smallest really square footage available, which is interior usable. Then we have retrofit called EnerFit. The retrofit program is wonderful, and that is also something where the Passive House Institute is still one of the few outfits that provides a clear retrofit path and program. 25 kilowatt hours per square meter a year. There's some other parameters around that, and I should say we won't go deep on that today, but they have different retrofit tracks. There's component-based, there's building-based, and there's also phased retrofit. All of these are in recognition of the challenges of retrofitting the built environment. And so as far as that goes, it's a fairly mature and really great program. And for those interested, and once we are able to go out and about again, we actually did the very first cold climate retrofit under this program anywhere in the world here in Minneapolis some years ago. And so there's a great project that we've had on annual tours a number of times that illustrate how to do that. And then there's new construction. That's what I'm standing in here today. The heating energy target there is a little tighter, 4.75 kBTU square foot a year. Another target, this is an alternate for heating, is the on-demand heating / cooling load. If you were in a cooling-dominated climate, this would all basically work in reverse for the cooling loads, but 3.17 BTU per hour and square foot, or 10 watts a square meter, is a target that the Institute would like people to achieve. I will tell you, in a very cold climate like ours, that's a unicorn, especially in single-family home. We can't do that, and that provides us with some paradigm shifts we'll talk about as well today. But if you can design a building that lives within those means, the reason why that is something that they encourage people to do is you can actually supply the little bit of heating energy this particular building would need through the ventilation system alone, and forego any freestanding or additional heating system for the building in its entirety. And in some parts of the world that works handsomely. It doesn't work in Minneapolis and Minnesota because our temperature swings are just too great for that, especially on the cold side. Airtightness is another target. This one not measured per square foot in year. It's a simple ACH 50 or CFM 50. There's some debate in the passive house community over using other targets and looking more at mapping the imperfections onto the envelope. And the FIAS program, which is an American variant here, looks at it differently. But this is how the international standard does it still. So ACH 50. This works for small scale, medium scale residential or other small office buildings and things like that. When you get into large scale buildings, big multifamily or high rises or something like that, they have a schedule or a program where they derive target specific to that building. For those of you who know and understand this, these metrics work well for buildings at a certain size. When buildings get much larger, other metrics need to be looked at because this would be too general. Generally speaking, though, 0.6 ACH50 for new construction, and then for the low energy building and the retrofits 1.0. And 10, 15 years ago, when we talked about this, people's jaws would drop and say that's impossible. And as you may know from your practice, you know, a lot of builders can now achieve a 1.0 in new construction out of the box. So that gap has really shrunk. And we've seen buildings that we designed as low as 0.18. Source energy targets, here we're tracking the energy all the way back to where it comes from. So in the case of electricity, if it came from a coal-fired power plant, you would basically look at the loss factors in that supply chain. The reason why this is a target that Passivhaus is interested in is because that is generally where pollution is associated. So if we're looking at the carbon footprint, that's where it's actually happening. And so by changing the use on site, obviously with loss factors and everything else, you have a large impact on lowering source energy. And so that's why we're tracing it all the way back. And also this allows you to account for various fuel sources really well. And so I think this is a really powerful metric then again, to make sure that we're reducing carbon footprint as a society on whole. So very forward thinking to not just focus on site energy or user energy in the building, but actually go all the way back to the origins and govern that that has to hold itself below a certain metric. Any questions on the general parameters before I dive into this here?
Yeah, we had a couple come in. If you can just explain the concept of the usable square foot
Yes.
a little bit more.
Yeah, I can. So originally, this program was inspired by stuff that was happening in the US in the 70s, 80s. I didn't give you the whole history, but it was really refined and developed by the Passivhaus Institute in Darmstadt, Germany, and Dr. Wolfgang Feist, who is still to this day looked at as sort of the father of Passivhaus. And so because of its origin in Germany, they used a there's a real estate and sort of rule book that governs how usable square footage is to be calculated in that country. They instituted that so that it's done in the same way, so that whether you're a real estate agent, a home buyer, a renter, you know, whatever, if we're communicating square footage, it's always communicated in the same way. And so Germany has this sort of guideline on how that is done. Generally speaking, what you're doing is you're measuring net interior, so basically from wall surface to wall surface inside. And there are some small little subtleties where if you have a compressed ceiling height up to 0.5 meter, so about, what is that, just under 2 feet or so, you have to subtract that out. And then certain ceiling heights count at 50%. And then if you get above a certain ceiling height, you count 100%. We generally don't count stairs and or storage rooms that are really not meant for habitation. So there's a guideline around that that is accessible. But generally, if you're just getting into this, if you just use the net interior usable square footage for that metric, that's going to be acceptable, and that's going to get you very close. You know, minus again a couple of oddities that you would learn either in your Passivhaus designer course or when you go through a certification.
Great. And then we had a couple come in kind of around the certification itself.
Yeah.
If you could maybe explain the difference between Passivhaus International or PHI and then PHI US, and then also if there is a kind of post-construction test that happens to demonstrate that the house is performing as it was modeled.
Okay, yeah, I'll start with that. So the International Passivhaus Standard is certified based on design and some field testing and field documentation. That's not something I want to go too deep on today. That we could do a follow-up session where we talk a lot more about those logistics. There is not in the international standard a follow-up once the building is occupied. It is essentially similar to a miles per gallon rating on a vehicle, where a vehicle is designed, it is submitted to the test, and it exists under those conditions. It can do a certain thing. And then what people do with it is up to them. And so think of it in a similar way. The building is set up for a certain level of performance. How it is driven, how it is lived in is up to the individual. Now, the Passivhaus Institute has done umpteen studies on how they perform in the field. So I'm not trying to say that they ignore that, but it is not part of the standard. It is just part of the research work that they do. And they actually find that on average, they perform as designed. So with the usual outliers that you would get, the energy misers on one hand, and the people who don't care because they think they got it all covered. Anyway, so that's one piece. The other thing is also on the difference between FIAS Plus and Passivhaus International. That's another rabbit hole we could spend a lot of time on. They, under the hood, they have the very same origin. The same person that founded the Passivhaus US Plus program there, Kathleen Klingenberg, she was a PHI certifier originally, and then she was departed and started her own building program. So they come originally from the same place. So they have very much the same ethos, the same paradigms. Where they vary slightly is in what metrics and what data sets, and also in the certification process. There's some real great differences there and how that is facilitated. Again, I don't want to spend too much time on that. So they vary a lot in logistics and a little bit on targets, but in principle, they came from the same place. And while FIAS Plus is changing more so over time still, because it's a young program, I think it still shares a lot of the key principles, but in the subtleties, it is moving and developing a little bit away. And as best as I can tell you from my experience, the FIAS Plus targets can be a little softer. And easier to achieve, and some of the component requirements are less stringent. And what that does is it allows more people to engage with that program, and perhaps to save a couple of bucks because you can use some items that wouldn't be suitable for an international standard building. On the flip side, though, what you get is, what you put in is what you get out. So if you drop some of the performance or the requirements on the front end, you end up with a building that has perhaps a larger energy and carbon footprint than on the tail end. So that's what I've seen. We did the very first dual certification project many, many moons ago. And so I can speak to that based on what I see coming out of these two programs. I hope that satisfies it for now. And again, if you want to go deeper, we could do other sessions with more focus. Okay.
Great. Yeah, why don't you keep moving?
All right. So we'll talk a little bit about performance by design, how to set up cold climate Passivhaus for success. I keep using the word paradigm shift a lot, and here's my attempt to visualize that for everybody. So again, in the status quo, we rely on active systems, and I love that photo. I'm so glad that I found it because I've been in that building. You probably all have too. Some of you probably have to be in that building every day, not literally, but you get my point. And it's, the status quo can be a sad state of affairs for us who are in the high performance realm because we see how much energy is squandered. But the point here really is that, there's some very distinct measures that we take to get away from those challenges, meaning, again, in the form of air tightness, super insulation, the balance heat recovery. And if you do all that right, you can heat it with a candle, quite literally. So again, I just want to hone in some of those principles so that you have that at your disposal when you want to talk about Passivhaus. Cost. The first question I get from anybody is, how much does a Passivhaus cost, or how much more does it cost, or how long until I make my money back? There's umpteen different ways. And the main takeaway that I want you to have from this question, or my experience with that question, is that the cheapest Passivhaus is always the one that is designed from the outset to become a Passivhaus. if you don't use the paradigm and principles set forth in that program, and you're just trying to bend conventional buildings into a passive house, you're definitely going to make it more expensive. And in the worst case scenario, it becomes as or more expensive as the real passive house, but you don't end up at the same level of performance. And quite honestly, that was something that drove me as a designer from my prior job into what I do now, because we were doing the better building. So we had everything from solar on the roof to geothermal in the ground to spray foam in the wall and some triple pane windows, but it wasn't a measured approach. We were throwing everything but the kitchen sink at it. So it made the projects very expensive for owners with an uncertain outcome and no focus on cost efficiency and fine tuning of assemblies to make a whole that is better than the sum of the parts. And so the key factor here is it has to be designed from day one to be a high performance building, and then it has a chance to be extremely cost competitive. With some of our commercial clients, we've demonstrated that the annuitized annual ownership costs can be down as much as 5 or 6%. And if you're a real estate person, you're getting excited at 1%. So I think if you wanted to make this very simple, you could also say, it doesn't cost any more, you pay for it differently. I've heard people use that sentence. What's definitely true is your upfront costs are higher, your down the line costs are lower. So that paradigm change is similar to what we do with solar. You invest in a panel and then you reap the savings, or in an electric car, you pay for the big battery and then you reap the savings. This is no different. The building is the battery that you invest in, and then you reap the savings. Let's get into some of the design things that are super important. Siting, especially single-family homes, they require passive solar heat gain to meet the standard, and they really feed off of it very, very well. This is the site in St. Paul, by the way, that Eric, that you came and visited. This was done many moons ago before we even had the design for the building. But understanding, where is the sun, where are the views, where is the shade, all those things are super important. So we try to study that hard up front. We work very intensely with our surveying partners to make sure we capture all the shade objects and everything that affects the site. And then, of course, when we design the building, we take that into account. It's something that is all too often overlooked, especially when I go into subdivisions and I see a building that essentially is turned and all the windows are facing the wrong way, where you get a blank stare on the south and all the windows on the north. And it shows there's no understanding of where the free energy is and the sunlight and daylight is. It's also a balancing act. I'm showing you here an extreme from that house in St. Paul. Any passive house architect and designer will tell you, well, that's overglazed. And I agree. So I'm basically shooting myself in the foot here. But it is a balancing act between inviting the sun in and keeping it out. The reason why I do show this photo is because on the flip side of that coin, we do pick up some design freedom. And so when we have a fantastic site like that one was, with an incredible view in the middle of the urban core, we can allow ourselves a facade like that and take advantage of all that and not pay a huge penalty for it. And that is one of the, again, more comfort-related pieces that come out of passive house. Now, architecturally, we can do some stuff that in conventional design be a no-no. You would have to put strip vents all the way across that, or put a fin tube across the bottom to make this bearable on any level. Obviously, we got to consider the climate that we're in. That's really important. Passive house responds to where you make it, and so thereby they look differently depending on where you are on the planet. We're dealing with very cold climate most of the time, but they also work in tropical climates. Like I said earlier, some of it works in reverse. The insulation, airtightness still work for you. And the window is looked at most differently than if you're more concerned with shading than with free heat. For small buildings, the sun is everything. 2/3 of the home that I'm standing in is heated by the sun in an average year. So if you can get solar heat gains, they are a wonderful thing. If you cannot get them, you may not be able to achieve all the targets of the Passivhaus standard. And the good news is that's okay, because they have a lower level entry certification. Generally, people can achieve that. And both of those standards are 80–90% away from the status quo. So the difference between them, between those two in Minnesota, is the difference between a harsher and a milder winter, maybe a couple of $100 of cost to the owner in any given year, and that's about it. So almost indistinguishable, but we're far enough away from the status quo to make that tick. So orient it well and keep it compact and keep it simple is maybe something I should add here as well. When we design, especially small single-family duplex-type buildings, keeping the building envelope simple helps with cost, helps with design, engineering, and also keeps the energy balance better. So trying to make simple building shapes. A lot of people accuse Passivhaus people of oversimplifying structures. They're all boxes. I think in part what you're seeing there is also, since that's a more contemporary way to design, you see probably more modern people gravitating towards it. And that's just a form factor that modern architecture uses. So at any rate, you know, the simpler you can keep the building, the less intersections, weird innies, outies, up, over you have, the easier it gets. And a compact building envelope with a better surface to volume ratio is going to be a more efficient building. Thermal bridge free is super important. Again, I know some of you are into the building sciences. There are standard metrics around this. I won't go deep there, but it is imperative, especially in a cold climate like ours, to keep the thermal bridge at bay, just because they also provide a risk on a building science level for early building degradation that we don't want to take. So it's not just an energy penalty, but those are areas where buildings can and will fail. So they need to be dialed out, and that's a design exercise. And then this is sort of the transition into the build portion. It has to be crafted meticulously. We have sort of an industry here now where you get the sort of 80-20. Most people want to get out of the project at 80%, and that's a job well enough done. You know, when you're doing a high performance building, doesn't matter if it's a Passivhaus or what it is, you really have to craft it perfectly in all the details, because it relies on that for it to function properly. And then another piece that I can't stress enough from our experience, you know, go team. So don't just sit at the same table, but work together. Listen to the concerns, lead with knowledge, experience, and confidence. Each team member has to live up to the highest expectations. We've often likened that to an Olympian. You know, how are they successful? Well, they got the coach, and they got the massage therapist, and the physical therapist. And, you know, it's a team effort. There's a bunch of people standing behind them to make that performance possible. And here it's the same. We really have to do this with our partners. Anybody involved, from the surveyor early on, structural engineer, to the contractor, subcontractor, they have to at least want to do it. They don't have to be experts at doing it when they start. We can help with that, but they have to at least want to do it, and have to be open. And we have to take their concerns seriously, and we can, in the design, reflect some of those concerns and work around them. And the last point is one that really, I mean, I don't know if you've seen that in your practice, but there is a tendency in our marketplace for profit grabbing. And it happens in particular when owners, developers, clients come forward and say, I want to do something different than the status quo. There is a huge tendency in the market to make that a free-for-all. And so it's really important to set expectations around that at the beginning of the project and say, we want a complete delivery of services, nothing more, nothing less, and we want that for a fair price. Just because we call it Passivhaus or something else is not the license to, again, double or triple fees for the same work. Questions around the design side?
I think we can keep going.
All right, let's do it. So then we get into some engineering. There's no way around that here, as is in other building standards currently. We got to use an energy modeling tool. And in this particular case, we're using the PHPP, Passivhaus Planning Package. Currently in version 9, you can see that's been around for a few years. I think this is going to go online at some point in the future. I can't say that I have any dates on that, but I do have some that on good authority that they're looking to get this away from a proprietary thing to something that's more accessible. The PHPP today is a steady state climate-based energy modeling tool that lives in Excel. Or other spreadsheet applications, I should say, if you're using Open Office or something like that, that works as well. But it is a spreadsheet-based model. It is climate-based. So it picks up climate data for your location. We've had some instances here in North America where climate data wasn't available, or we're dealing with a microclimate. And in that particular case, we go back to the certifier and they furnish a specific climate data set for the application. That, by the way, is something that FIAS Plus does quite extensively as well. The main modeling output parameters, of course, space heating, heating load, cooling load, risk of overheating, and then we get into large consumers, hot water heating, electricity use, all of those things. It's all in there. I will say that the building itself is essentially modeled under a model or a unified user pattern. So it assumes a certain occupancy and user behavior, and that is uniform across the models. And that is so that we can compare them. I think that's, again, one of those hugely helpful bits of the Passivhaus standard, because I can talk to somebody in Australia or Germany, and we can compare our models, and we can speak the same language and understand what's going on, and we don't have to concern ourselves with the fact whether the person who's living in the building is an energy miser or somebody who doesn't care, because in reality we don't have any influence over that anyways, and so in a way it doesn't matter. It's important that we also go after the 800-pound gorilla, which generally is space heating or cooling, and that we do have a lot of control over, even foregoing user behavior. So from that angle, I think this program is really strong in that regard. It's a design tool. I said that in the beginning, so it gives direct feedback that is hugely helpful in understanding when you make design choices. Where do I put a window? How big do I make it? Is it shaded or not? All this will come through, and there's various interfaces throughout this tool to deliver that feedback to me as a designer and allow me to make good choices. And then also it has a tab or a column in this case here on the right-hand side for whether I am meeting certification criteria that I am after. This here happens to be an IP version. There is an IP version, by the way. I often have SI examples just because I grew up in Germany and I still do a lot of work in metric, but it is a global program. It is used literally on every continent, and so it is available here in North America in IP as well. Don't want to go through the whole thing here, but basically what happens in a PHPP is you're optimizing the building using the energy tool feedback, and there is a certain order of events in which you enter the information so that you get to meaningful input and output quickly, and can make the big choices that you need to make. And then from there, you can drill down to much smaller selections and choices. The program is so detailed that it will calculate the heat loss associated with your vent stack or radon stack or the cold water line coming into the house. So it's very, very finely tuned. But obviously those inputs, as they become more minute, are not driving your design necessarily. So you can forego some of that or keep it sort of in a default state and just deal with the big picture stuff. One thing that I don't have in here, but that's also cool, is they have an extra tool called Design PH that is based around SketchUp that allows you to schematically play with Passivhaus before you really get into full CAD and full PHPP. So then some bits here, being pragmatic is always helpful in my experience, especially when you're dealing with it in a cold climate. So the air barrier, of course, comes to mind. That's the holy layer. Nobody messes with the holy layer. That was one of my clients named it that, but I think that's well put. Engineering to an exact half-inch of insulation is not necessary. You could be pragmatic. You use what's readily available, and you keep it simple for people. We try to use what's readily available, and that is encouraged. And actually, in the Passive House program, there are some exceptions too. If something's not available to you locally or it is cost prohibitive, and you can make that argument, you can get a Passive House certified with some exceptions if they should be needed. Find expertise when you need it, really important, especially on the building science side. There's not a whole lot of that in the marketplace. So I can't stress that enough, especially if you're playing with new assemblies and things like that. Make sure they actually work. And if the building science isn't understood, we need to bring somebody in who can explain that. One key finding that we keep having because of where we are on the planet, the best window on the market could still be much better for a very cold climate zone. So when clients tell me, oh, this thing is just massive and it's too expensive, that is usually what I tell them. It is still the weakest link in the building envelope today because of the technology we have. Shading is not optional. I would say asterisk there is if your building relies on high solar heat gain. As I mentioned earlier, large buildings rely less and less on that. And so there are some exceptions to the rule. But when we're dealing with smaller scale buildings, it is very important for occupant comfort. Another point that some of my institutional clients struggle with a little bit, sometimes a single spec is all that will do, and that's okay. I say that also as an architect with liability. I want to understand the components that are used and not have somebody willy-nilly at the last minute exchange them for something else. Building science is a finicky thing, and so we want to make sure it works. And then point 9, I was just at a webinar with Dr. Feist where he talked about the impact of passive housing, climate change. I think if it saves in the long run, this was meant maybe more for economics, but it's true for carbon as well. It is the better choice. And I think that's something where as a society, we need to get more on board with that. And the last one, open fires, combustion and exhaust only devices will not work. In an airtight building envelope, my house here had a leakage of 75 CFM at 50 pascals. You can all imagine open fires, combustion and exhaust only do not properly work here. Okay, I don't want to go too deep on that here. I'm running a little behind. Value engineering, the point I want you to take away from that is I think we need to look at what value really means and the engineering really means. Again, most people don't like that term much, and I've seen people refer to it as devalue engineering. Our industry is plagued with that. So I have some points here. I'm sure we'll share this after the fact, and you can read that on your own time. So from there, I want to give you some examples. Are you ready for examples, or were there questions here?
I think we're ready for them.
All right.
Examples, yeah.
Let's do it. So I'm going to go through these by category, just because I want to hone in these categories with you. So we're going to talk about those 5 paradigm shifts once more. Continuous high R value insulation. So that starts in the office with a good design. And when we say continuous insulation, we mean that. Unfortunately, my mouse doesn't work, but if you start in the lower right-hand corner, this is a complete building section cut through one of the buildings that we designed for a client. You can see the insulation, everything yellow is insulation, starts below the slab, wraps the slab. This particular slab has the foundation built in, so it's a structural slab. Then the building sits inside of basically a casing of building insulation, which then comes up out of the ground, sometimes transitions to different materials above grade. This was an all-exposed concrete home that we designed, but the point is it is continuous all the way around, even below the structural components. This you can dial in with your structural engineer. There's no problem there. Some of the biggest buildings in the world, and every bridge that you've ever driven over, every tarmac runway on an airport that you ever landed on is generally footed on foam. And so insulation materials work well in that application all the way around. This is an example. I show this picture because it gives you an order of magnitude. We don't do that anymore. The layering of 4 layers of foam is cost prohibitive, is a squandering of labor. But there was one project where somebody insisted on doing it that way. And I think the visual is strong. You can see there's about 4 times as much insulation here in this passive house as there would be in a conventional design today. Continuous then also means dealing with any protrusion or hole. You can see that here. So we got a subslab, or actually this was a ground source preheater for a ventilator. We got the piping coming through. So taking care of filling those voids. Same building, same challenge there. It was an exterior insulation finish system consisting of many layers. Don't do that. But again, for the illustration, I think it's strong because it shows you, again, we're typically about 2-3 times code level of insulation for residential assemblies. Wood construction, this one here on the left-hand side, the part with the tape on it would be a 2x4 or a 2x6 structural frame that is air sealed to a sheathing material that is used as the air barrier. So this is our rough opening, and then a TJI or I-joist is used to make a secondary wall cavity for more insulation. So this is shown here at the window installation, but this is a great way to think of wood construction. How do we get from the 2x6 box to a super insulated box, air sealed? This is one way you can do it. Use the original structural sheathing as an air barrier, tape it to your rough opening, add another cavity to the outside, fill it all up. This is what that looks like when you look at the whole box. This is, by the way, that retrofit. I know it looks like new construction, but there is actually an 85-year-old building in the middle of that. And then it gets filled with insulation. We do a lot of work with wood and cellulose just because of the embodied energy implications here. No rocket science here whatsoever, just labor and materials. Continuous air tightness, I touched on it a little bit. Starts with a good detail. We generally do color coordinated plans. We use red for the air barrier. I don't know if it comes through on your end. There's a little detail for a wet flashing system and some connection points in this detail here specifically. And then on the right-hand side, there is that detail executed in the field. First and foremost, air tightness revolves around an understanding of how pieces come together or protrude. And then the second piece is managing it. The tools of the trade generally look like this, all stuff that you can readily pick up at your hardware store. The tape in the middle, a high quality tape. Again, 10, 15 years ago, that was exotic. These days, there are umpteen resources where you can pick that up readily. And then just taking care of doing a good job of sealing the components together that need to be sealed together. However that looks in the field. These are just some impressions from random projects that show you, what that is in the field. This is maybe worth talking to for a second. A lot of times what we'll do at the lid is create a dedicated service cavity. So what you're looking at is an OSB sheathing fully taped up, used as a vapor retarder and air barrier towards an attic. And then below that, a service cavity. I believe these were 2x6s that are used to run services. It's great to separate that out. It's not required, but it is a great way to do it because now we don't have any weaving in and out of the airtight barrier of any of the services. Same thing here, building exterior. The initial building was sheathed and air sealed. You can see the taping on the sheathing there, and the electrical meter that needed to go on early being stood off so that it is suspended out there and that there aren't any thermal liabilities between it and the rest of the envelope. So, just little things like that can make a lot of difference. And then obviously we measure. We measure a couple of times. You only have to deliver one successful blower to a test for certification, but for practical reasons, we usually do a rough-in test, and then we do a final test. And that's all the tools that I know you have in your company and in your arsenal. I have found, though, that a lot of people aren't familiar with the D and the E ring. So if you want to test a Passivhaus single-family home, you need the D and the E ring, or you need to bring a duct blaster. Either way, that works. Yeah, so here's a 4,500 square foot home that got tested with a duct blaster. This I don't need to dwell on. I know a lot of you do this for a living, so we just test and we look at where leaks are, and we fix them, and then obviously if you use Tektite or whatever other tool, you get an instantaneous readout from what that all is or was. So with that, I jump into the thermal bridge-free design, because that is sort of a nebulous thing for most people. What does that even mean? Well, I think Hans-Jörn Eichu's video I usually play describes it as a superhighway for energy to travel from in to out or out to in. And it's generally when you have dissimilar materials next to each other where the conductivity varies, and you have some kind of a bypass potential for a certain amount of energy from the inside to the outside or vice versa. This can happen particular in attachment details around windows, openings, protrusions, structural details, foundations, what have you. And I would say there are point thermal bridges where you have just a single protrusion, like one point where that happens, but there are also linear thermal bridges where maybe there's a poor detail that extends an entire perimeter of a rim joist or a slab to wall detail or something like that. And so they have varying impact. We need to quantify that and ideally dial it out. These are just some simulations and photos of where you can see how something makes a difference. On the left-hand side, in this picture, I show a tip-up concrete building that is insulated on the interior with a floor slab that attaches to the tipped-up concrete wall. That, by the way, came from a LEED certified student housing project we worked on. We consulted on making it better. So that's the standard condition, and you can see there's some pretty massive thermal bridging. We actually showed the owner that the whole perimeter in the winter, that interior floor slab will be at frost temperature, and that's in conditioned space. So by taking the same insulation that they had on the inside of the building and flipping it around, putting it on the outside, you can see the isotherms on the right-hand side. You forgo any thermal bridging whatsoever. So in this case, that doesn't really cost any money. It's just a different way of thinking about the same thing. And by the way, that psi value of 0.01 watts per meter Kelvin, that is the defining criteria for what is a thermal bridge that needs to be considered and not. So if it's less than that, or if it's a larger number, you need to consider it. If it's less than that, it's considered thermal bridge free. I'll show you some Passivhaus windows and doors and talk about the solar heat gains. This is a photo I took many years ago when we didn't have much access to these units in the American marketplace. That's fortunately completely changed as well. This is generally what a cross-section of in this case, three different types of Passivhaus windows looks like. These are all meant for cold climates like ours. So again, this might look differently in a moderate climate, but that's generally what we see here. They're made up of argon-filled triple pane glazing units with what is considered a Swiss spacer, or a very low conductivity spacer around the edge of the glazing, and then generally a thermally broken frame of sorts. You can see these are some beautiful examples using hemp and cork as insulation materials. And then on the right-hand side, there's one that uses a composite and foam. Again, just like in any building, we have choices in the marketplace. These are just a couple. Here's another cross-section of a window. This is actually, yeah, that's the same window that I'm standing next to here in my building. And then inserting it into a wall, if you have a heavier wall, that means something, or a thicker wall, I should say. So it has some design implications and how we deal with that. We need to get the water out. That's something to consider. We need to put a shade in, perhaps. That's something to consider. We need to trim it differently, but we have different opportunities. Now we can look at meaningful windowsills and how we treat them. And rest assured, you can do this in a classical or traditional way. You can do this in a modern way. It's a limitless opportunities how to deal with that on the design side. It's important to understand, though, how you put it in. This was a window detail that we used 10, 15 years ago, again, in the early days on a project. Illustrates a little bit where the window sits, how it is fastened, how the air barrier and vapor and weather barrier are attached to the window. So this is the kind of stuff where the design and the architecture change. And then obviously in the field, as I showed you earlier, somebody has to take some care to actually execute it like that so that we don't have any failure points. And if it's put in properly, then we don't have any thermal bridging. Oh, the other thing I wanted to mention here is for the window is really important to understand the specifications. I find that, unfortunately, with a lot of the North American vendors, it is very difficult to get them to go on the record and really give you, U factor for the frame specifically, not the frame with the glass, but the frame all on its own, and what spacer they're using, and where the glass is, and all of that. So for Passivhaus, you need to have detailed glass information, detailed window information, and that can be a little bit of a pain in the neck to get. Passive solar heat gains, they cover well over 50% of the heat demand. So here's an example of a building and how you're dealing with that. So this was my first passive house I designed. This is it under construction. And you can see here really well how the sun penetrates the space and falls deep into the space. That's how we utilize that. Here's the same picture with a finished product. So that's what the room ended up. We have exterior motorized shades on that building, as we do on some of our buildings. With a weather station that protects it from high winds. And you can, in this day and age, there's an app for that, like there is for anything. So you can actually automate these systems to track the sun and guarantee you better comfort, less glare, and other things like that. This here is sort of a quick manual animation of the shades going down and then going into a shade mode on the upper floor here. So that's what an exterior motorized shade looks like, but you could literally use anything in its place. You just have to provide something for the conditions that you're designing in. There's a close-up. So. All right, and then internal heat gains, they still provide about 10% of the heat demand. I thank Sony Pictures for this photo because I think it illustrates that really well. I didn't go into detail here, but that's heat coming off of the human body equipment and things like that that we have running and bring into the building, cooking, showering, washing, those types of things. And then we get into the more mechanical aspects of it. I'll give you a couple of examples of balanced heat recovery ventilation. This was a demonstration project we did in La Crosse for an educational facility some years ago. They had one of the earlier Paul Zender systems. What you see in the center of the picture, that white box, is the actual heat recovery ventilator. It's about the size of a mini fridge bolted up to the wall. Generally has 4 pipes. One is input and exhaust from the outside. The other 2 are input and exhaust from the building. And in this project, those gray boxes you see in the foreground on the ceiling are the manifolds. So basically, the air is being supplied to a central manifold, and then from there, home run to each room and return from other rooms. Generally, you supply to living and bedrooms, and you return from kitchen and bathrooms. Here's another close-up. These systems are now readily available in North America. Thankfully, that was a bit of a journey over the last 15 years, but they're basically everywhere now. There's just another version of the same thing. Once you get to commercial buildings, multifamily buildings, they look a little differently, and you have different choices. Here's an example of a centralized system that supplies a multifamily building. Swagon, we actually have a great representation here locally by Mike Woolsey, who is also very active in the Passivhaus community. So if you have any needs, reach out to him. Fountain of knowledge, great resource. This is an ERV. You can see the rotary exchanger right there, centrally ducted system for that particular building I showed, which I believe is a 12-plex or something like that. When you get to multifamily, you have choices. You can do it centralized. You can do it decentralized. This was a system in a daycare facility right here, and you can see there's just this sort of closet-looking area with a Zender unit in it on the right-hand side. And so in this particular building, there was an addition put on, and so centralizing the system wasn't practical. They also didn't have originally proper ventilation like many buildings here in the States. So what's happening here is they're basically planting individual units and then putting a small amount of ductwork for a certain area on it. And then we have distribution. You can hide it, you can show it. This picture, the brighter silver is silencers. So if it goes to other rooms, you can put silencers in. Here is a duct that is the distribution and outlet all in the same, with these holes that allow for the air to infuse. I know we're at 2 o'clock. I want to get through this next section real quick here, heating, cooling, dehumidification. Then we'll put in a stop again and decide where we go from there. So heating, cooling, dehumidification. I show the hairdryer. Why? Because in all of our passive house designs in the residential scale, that gives you an order of magnitude of what it takes to heat the home on the coldest day of the year. The house that I'm in right now can be heated with 2.5 hairdryers going at the same time on the coldest day of the year. So our heat flow comparison, again, I don't want to dwell on this. I just want you to grasp the order of magnitude can be reduced massively. In some of the retrofit work that we've done for clients, we've shown upward of 90, sometimes 95% potential. The heat loss is obviously reduced dramatically as well. So yeah, the heat loads are generally 3 to 6 BTU per hour per square foot. Cooling load is about half that in most projects. We've done this with simple systems. These are in-floor electric heating mats. Our first passive house has that. You're not covering even the entire floor area. You're covering just like area rugs, certain parts that you want to experience that warmth in. And I always have to remind people, this system is 100% oversized for recovery time. So in reality, we could have gotten away with half the amount of mats on that floor. Sorry. The other piece, and this is becoming increasingly relevant, residential heat pump systems. Again, you have probably seen these. So mini split heads is one choice. They suffer from distribution, not great. Split ducted cassette, we've used a ton of those in the early years. And so here's examples of that. These used to be in commercial vestibules. We've done buildings and residences on them. That's what they look like. The nice thing is you don't have a mechanical room. You basically just bang them into a ceiling and they're gone from site. And then the other choice is conventional ductwork here on the left-hand side being air sealed on a whole house air handler. So this is the unit in my house. And that's kind of where it's at present. That seems to be the weapon of choice in our industry here for residential heating and cooling and some dehumidification. And that talks to an outdoor unit, obviously, which you all know looks like that. I'll show you one example quickly of a commercial project. So there we can use the same technology just on a much larger scale. So we have indoor on the right-hand side, indoor distribution or register, then centralized register or manifolds and units. In some cases, we have what's called the hydro kit so that we can actually in the summer when we reject heat from the building, we can make hot water with that. And here's a schematic of a system that was designed for a multifamily building. So you can see the individual cassettes that went into units, the manifolds they connect to, all the way back to the outdoor unit. And then here's a schematic of that with heat recovery to hot water tanks. So these are options we have in the realm of heat pumps. So with that, I'll put in another break. And then I do have just a little bit more, but I want to be mindful of your time. So I'll let Eric tell me where we want to take it here.
Yeah, I think we can, people can drop off if they need to. But otherwise, if you have the time to keep going, Tim, we can kind of roll into this next section and then take any last questions after that.
Sure.
Does that work for you?
Absolutely. Yes, you got me. I'm here. And were there any questions on these last couple of sections here that really went through the 5 examples of the 5 items plus mechanical?
I don't think so. There's been a few little discussion about embodied carbon and how that plays into the passive house.
That's great. Yeah, it's wonderful. And I'd love to do something on that at some point too, as a lecture. As I mentioned, I was just in a webinar with Dr. Feist, and that was all about that. And I think, again, order of magnitude, it's important to understand order of magnitude. When you're building a single family home right now, a conventional home, the ratio of the embodied energy in that house and the operational energy may be, every 10 years or every 5 to 10 years, that building will cycle through the embodied energy, again, and operational energy. When you get to a passive house building, again, depending on how you build it, that is much extended. So you may be able to operate the building for 50 plus years on the amount of embodied energy that you put in the building. Now, if you make the choices on your construction methodology, you can amp that up further. And again, some generalities in the field. If you take a multifamily building that's built from concrete and steel, and now you build a mass timber building, you can reduce the embodied energy in that structure by about 80%. But keep in mind, if you're looking at the footprint over 100 years or something like that, if this is built as a passive house, the embodied energy in that building, again, is some fraction of the operating energy over that period of time, right? And generally, buildings churn in their useful life through more energy than it took to make them, that is embodied in the building itself. And that's especially true in conventional buildings. So we have to keep that in mind. I'm not saying don't worry about embodied energy, but you have to keep that in perspective. At the same time, I will say our firm really recognizes that, and that's why we really favor wood construction, cellulose insulation, and items like that, because we know we can reduce that footprint so much further and do a good job there.
And maybe just so people are kind of understand, could you describe just briefly what role you and your firm play in the process?
Well, as architects, we would pre-select, of course, all the assemblies. We would design the assemblies. And so we have a lot of control over that. We do work very closely with our build partners, and we do let them have a say and input into that conversation. But generally, we find those are accepted building methodologies here locally anyway. So that's not really a fight. I find that in residential architecture, it is actually more cumbersome to talk somebody into a concrete home than it is to utilize them for wood construction. So I think it's a very easy conversation. I think that's where the North American marketplace has maybe a leg up over other parts of the world, just because traditionally we have already built more low embodied energy, especially in the residential sector, than, let's say, Germany, where conventional construction was all masonry based.
And then we had a question come in on shading, especially kind of as it relates to maybe a modern versus a more traditional aesthetic. What are some different ways that shading is being designed, either in overhangs or maybe in a more modern approach where they don't want those overhangs?
Absolutely. So you can do any of the methodologies that you've heard of. They probably all work. So building overhangs within the confines of what they can realistically do, right? In Minneapolis, putting overhangs on the east and west facades doesn't work. Why? Well, we just happen to be on a part of the planet where the sun angle generally is so low, you get perfectly perpendicular sun ray coming at you. So in other words, your shading device, if fixed, would have to be infinitely long to try to capture the sun at that angle. Doesn't really work. So then you're left with maybe a traditional shutter or something of the like, or a movable element. Or you dial down the size of your glazing on those facades where that becomes more cumbersome to deal with shading. On the flip side, on the south side, when you look at where the sun is at in the sky in Minnesota in the summer, we go so vertical up high on south that I find if I have a 20-inch thick residential wall with a window set in about a foot, that window already shades itself just by virtue of where it lands in the wall at the time of year where I want that shading. So in a contemporary setting where I don't want an overhang, I don't really have to do anything for the summer. And so what I find is it's really the swing season, when the building just doesn't need any heat, but you're getting it from the lower sun angle. That's where you want to manage it. And so the important part here is understanding that and then dealing with it properly. And that could be anything. It can be trellises, fixed elements that you stand off. It could be shade sails that you put out there seasonally. It can be plantings, deciduous trees, wonderful. For some reason, Mother Nature figured out when to grow a leaf and when to throw it away. And we've utilized all those in our calculations and in our designs. And so the short of it is it's a wonderful subject to dive into, and there's many, many choices. And I find you can make it work traditional, you can make it work contemporary. It's just something that I encourage people not to forget. I've been in too many passive houses where it was an afterthought, or it was no thought, because it's something people don't usually think about. And that's why I stress it, because I don't want you to forget about it, because that makes people miserable. You know, if you have a multifamily building that is north-south facing, or east-west facing for that matter, you know, and in the morning, the one half gets completely hammered, and in the evening, the other half gets completely hammered. That's just not pleasant for anybody. So we do need to understand, where is it coming from? What are the angles, and what do we do about it? And again, if you look on the internet, you will find so many innovative and great ways that people have incorporated shading. So the key point is, don't forget about it. But the world is your oyster. Many choices.
Great. I think you can keep going with the last little section here.
Yeah, we got just a little bit here. So I wanted to touch on building science also, maybe something that's close to CEE's heart on some level, or at least some in your organization. It's important that you understand what you're designing. And I also find that since it's still early days for high performance building in North America, I see a lot of projects, people ask me for an opinion or whatnot, and I see a lot of crazy, can we do this? Layering of materials, assemblies. I really discourage people from that. If you don't understand it, please don't do it, or hire somebody to help you understand what you're actually making. I do that at times. I'm not that strong and woofy, and so I sometimes partner with people who are experts at that, especially when we get into new assemblies that may be forced upon us by regulation or material choices or something. It's really important to understand that. That doesn't mean you have woofy the living daylights out of every building, but it is something where I would recommend, if somebody wants to get into the practice, understand your standard assemblies that you're now doing. Make sure they're dialed in before you build them 50 times. We use something called the Glaser diagram quite a bit, which is a really simplified dew point analysis, just to kind of see where is the dew point, what are the materials there. So even something like that, really important. So then, one other little tidbit here, efficient appliances and equipment. We did talk about how the Passivhaus program doesn't really look at user behavior, and it uses a standardized set so that it's a level playing field, but obviously that still matters. So we encourage, of course, efficient appliances and equipment. Energy consumption, we want to reduce that dramatically in a Passivhaus, but you can see that, those components like plug-and appliances here or lighting, they remain virtually the same in the Passivhaus as they were in the normal building, conceivably, because those are different things. What TV you buy, what microwave you use is not impacted by this at all. So while there's a significant energy reduction in the building overall, from especially heating, cooling, maybe hot water, because we're smart about how we do that, there's still the pesky sort of plug load stuff out there. And so we do encourage people to look at that. By the way, I like showing this too, because it shows you this was done on a case study. That was the same house designed, normal Minnesota code, and then Passivhaus. And these pie charts are to scale. So you can see how much smaller that is, and how the distribution within the Passivhaus is completely different. So domestic hot water is really one of our main concerns in a Passivhaus. So with that, look at some smart solutions, wastewater heat recovery, LED lighting, I don't even have to talk about anymore, and appliances are what they are. I think we could have better appliances in North America, but you also got to go with what's readily available. Monitoring, I talk about that for a second just because it helps with the last section here. You can't optimize what you don't understand. So if I have a client who's interested, I always encourage them to do it, because then you can learn and you can improve yourself. I want to do more on that. If anybody at CEE is interested in monitoring the house that I'm standing in right now, please reach out to me. I'm desperately trying to find a partnership with somebody to monitor. And then renewables and emissions. Let's talk about that for a second as well. We find that in the Passivhaus, compared to code building, generally we're about half the emissions, maybe a little less. A lot of it is, the reason why that isn't a larger number is because we're switching natural gas mostly over to electricity, and the grid is what the grid is. This would look completely differently if you fueled it from renewable sources. entirely. So if Excel is carbon neutral in 2050, this would be 100% reduction just based on that. However, we're able to cut half of the carbon or more than half of the carbon just by shifting the paradigm of how the building is made. And I think that's really important. The Passivhaus standard has 3 tiers of accounting for that. So if you put solar panels on your roof, they have a plus and a premium component or track. The plus track can be thought of as sort of a zero energy track. The premium track is geared towards projects that want to be net zero at any moment in time. That is a very tall order, especially in Minnesota. So think of the premium Passivhaus as a building that can supply itself entirely on the coldest day of the year, either through seasonal storage or ad hoc production. And that is very, very difficult to do and leads to a whole nother subject. But the general gist here is fuel responsibly for carbon neutral operation. So we're reducing energy massively on the front end, making it from renewable resources can get us to carbon neutrality. Just a quick summary then of the key benefits, and we're through. Highest comfort, can't stress that enough. We have all interior surface temperatures near room temperature year-round, no radiant heat loss. Fantastic. Quiet, by the way, as well. I have next to me, just on the other side of the wall, I don't know if you could hear it at all, but there's a crew putting siding on this house right now. Indoor air quality, we have forced balanced ventilation year-round. Don't have to sell any of you on the benefits of that. Resource efficiency goes back to the question we had earlier about embodied energy. We're putting resources in a building once that stay with the building for a lifetime. Things like insulation don't need any maintenance. If you use the right insulation, low embodied energy works for the building indefinitely. That's great. We've made that investment and we bought that and brought that material once, and it works for us indefinitely. Case study after case study, doesn't matter where it is on the planet, people look at the super insulated high performance buildings and find they have cheaper life cycle costs. Not that that convinced people in droves to make these projects, because the concern is mostly for what's in your wallet right now, not in 5 years, but it is a universal truth. It is also true in Minnesota. Generally, over the course of a mortgage, you're well ahead on the Passivhaus versus standard build. And then the climate action piece. I love that graffiti, by the way, in Berlin, but it's just time. It's been time for a while, and we offer some good answers. So with that, I close. I hope you got a good broad overview of what the program is, what it delivers, some examples of how that works. I'm here. If you have any questions, just reach out. Eric can pass on my info. You can pass on this lecture. We can go deeper on different subjects. I love talking about it. I also want to invite all of you to get engaged. I think the Passivhaus community is really the spearhead of high performance building in North America today. These are some great resources right here and places you can engage. We have with NAPHN and Passivhaus Minnesota a partnership that is local and national to the United States. Right now, we're offering tons of free online webinars, really exciting content. And so with that, a quick plug, the annual conference, June 11th and 12th, for obvious reasons now online. It is going forward. It's $100, I think. So amazing price. These are great. Attend that. Designer training. We've been working so hard to get designer training rolled out in all parts of the country. Thanks to COVID, now we can do this online, which is almost better. So it's a level playing field. Anybody who wants to become a certified Passivhaus designer or consultant or tradesperson can now join these things online. NAPHN's website is your best starting point. So these courses are all going online. So with that, I thank you for your time. I appreciate those who stayed behind. I'm sorry it went a little over, and thank you very much.
Thank you, Tim.